This video is covering section 2.5, implicit differentiation. We use implicit differentiation when we take the derivative of functions that are not explicitly in terms of x. That is, if you look at example 1, xy squared minus x cubed y equals 6, there's no way that we could isolate the y value for this equation in terms of only x. But it's still a function that we are interested in taking the derivative of. But when we take the derivative, we're looking at taking the derivative with respect to x. So if you look at the first guideline, it says differentiate both sides with respect to x. This has a lot more meaning now that we're looking at different variables as well as x. So in the past, we took the derivative with respect to x, but of x terms. So there wasn't really anything complicated. But now we're taking the derivative of both x and y terms with respect to x. So what happens when you take the derivative of a y term with respect to x? Something a little bit different. So let's look at this first example. We want to take the derivative, just like normal, of this first term, xy squared. This is a product, so we're going to have to apply the product rule. So the product rule says we're going to take the derivative of the first function being x, so that is 1. Derivative of x with respect to x is 1, times the second function, y squared, plus the first, which is x, times the derivative of the second term. The second term is y squared. Now here becomes a problem. We're taking the derivative of y with respect to x. This is actually going to apply the chain rule. So remember, the chain rule has a function inside another function. If you think of y as a separate function here, that's how we're going to look at this. So y squared, the derivative would be applying the chain rule to y. But then we have y, think of it as another function. So we have to take the derivative of y. The derivative of y with respect to x. What is the derivative of y with respect to x? Well, we don't know. That's what we're looking for. So we're just going to notate it, derivative of y with respect to x, which is dy dx. Okay, so that's the first term there, and I'm going to put this in brackets so that we know that that whole thing right there represents the derivative of that first term. So now we're going to move on to the next term. We have the minus sign. So again, I'm going to put minus and then brackets. And this is important because the next term is also product rule, which means that minus sign right there is going to need to distribute to both terms. So product rule again. Derivative of x cubed will be 3x squared times the second function y plus the first x cubed times the derivative of y. Again, derivative of y is 1, which I'm not going to put that, times dy dx, the derivative of y with respect to x. Okay, so that's the first side. Now, remember, we need to differentiate both sides. That's also something a little new here with implicit differentiation. Instead of y equals something in terms of x, we have this different form of an equation. So we need to differentiate the other side, again with respect to x. So we have a constant 6, derivative of a constant, just 0. Okay, now, we're not finished. Okay, we've just done the first step. The next step says to collect all the terms involving dy dx on one side and all the other terms on the other side. Now before that, I do that, I like to clean things up a little bit. So I want you to go ahead and pause the video, and I want you to clean up what we've written here, and then we'll move on. Okay, so hopefully you've cleaned it up and it looks something like this. Now I'll show you how I notate my things. So when I clean this up, so x times 2y times dy dx, I'll rewrite it as 2xy. And then the dy dx is still with that term, but I put a little dot here just to kind of separate the dy dx a little bit, because that's what I want to isolate. But I still want you to understand that this whole thing here is a term. Okay, so when you separate that, it has to be divided out. So we're looking for our terms that have the dy dx. Everything that does not have the dy dx, we're going to move by adding or subtracting to the other side. So I'm going to do kind of 2 steps in one. I'm going to isolate or factor out the dy dx. Our first term being the 2xy term, and the second term being, that should have the negative there, but minus x cubed. Then we're going to add and subtract our other terms. That gives us a positive 3x squared y minus y squared. Then the last thing you have to do is just get dy dx by itself. So dy dx is just being multiplied by this factor, so all we have to do is divide, and it's very simple. So we have 3x squared y minus y squared divided by 2xy minus x cubed. Now we have finally solved for dy dx, so therefore this is our answer. Okay, for our next example, we're going to look at another chain rule, so sine of xy. So again, we're going to take the derivative of this, and notice that I said sine of xy, but it's actually the equation y equals sine of xy. So when we take the derivative, implicitly we have to take the derivative of both sides. Now, in the first example, I used dy dx as my notation, but you can also use y prime. So I'm going to use y prime this time. So the derivative of y is just 1 and then times dy dx, but instead of dy dx, I'm going to use y prime. So the derivative of y is y prime equals derivative of cosine of xy. This is something that trips a lot of people up. So again, we're going to use chain rule, the outer function sine. Derivative of sine is cosine of xy. Now here's the tricky part. This is chained, so I'm going to multiply by the derivative of the inside. The inside is a product rule. So that cosine of xy has to be multiplied by both things. So we're going to put a big bracket here. Derivative of x is 1 times y plus x times y prime. Now, this is not finished. You do have y prime or dy dx, but you've got another y prime sitting over here that you have to isolate. So we're going to distribute the cosine into both terms. That's something very, very important that you've got to make sure and get. So we're going to write y prime equals, I'm going to put the y in front, cosine of xy, plus, and here I'm going to put the x in front, cosine of xy, but I like to keep that y prime term a little separated. But again, that dot here to show that it's still with that same term. Okay, so I want to pull all the y primes to one side. So I'm going to do 2 steps here. I'm going to be subtracting this term from the left side. So I have y prime. And I'm going to go ahead and factor out. Hopefully you'll be able to follow along with this. So if I factor out a y prime here, you're left with a 1. Don't miss that. Then minus the x cosine of xy. That does not look good. There we go. And then equals y cosine of xy. I'm not writing my y's very well. There we go. Okay, so then our last step is just to get y prime by itself. So again, we're just going to divide. So y cosine of xy divided by 1 minus x cosine of xy. Okay, so just a couple of things to watch out for there. Okay, my last example is going to look at finding the second derivative using implicit differentiation. Now, if you look at this example, this is a circle, x squared minus y squared equals r squared, which I could write explicitly in terms of x, but then I would get the 2 functions, the plus or minus square root. So really, this function is considered implicit because if it was going to be a function, it would be a circle, right? Which is not a function of x because it does not pass the vertical line test. So we consider this an implicit equation because it's not a function explicitly in terms of x. So that's how we're going to approach this. So we're going to take the derivative, and so we have, it's pretty easy for this one because there's no products or anything. So we have the derivative of x, which is 2x. Then the derivative of y, which is 2y, but remember we're taking the derivatives with respect to x, so we need to multiply by either dy dx or y prime, whichever you prefer. And then equals 25, the derivative of 25 is 0. So it's pretty simple there. And then we're going to solve for y prime. So subtract 2x, divide by negative 2y, and you just get the ratio of x to y. And this is a pretty common problem that you'll see because of how it turns out. Very easy. But this is just the first derivative. Now I want the second derivative. So again, the second derivative we're taking with respect to x. So we're just going to start right off where we're at. So y prime, the derivative of y prime is y double prime, the second derivative. And now we have a quotient. So we're going to apply the quotient rule. So hopefully, I don't know what Mr. Kondasar taught you, so here's how I remember the quotient rule, and that's low D high minus high D low all over low low. And essentially what that is not low law, but whatever, is the low function, so y times the derivative of the upper function minus the high function minus the derivative of the low function all over low low, which is the low function squared, or low law if that is what you prefer, since that's what I wrote. All right, so we're going to do low d high. So the low is y times the derivative of the high. Now we're taking with respect to x. Derivative of x with respect to x is 1 minus high d low. So x times y prime, all divided by y squared. Okay, now there's something that you can do here, because it says in the instructions, so we've found the second derivative, but it says we want the second derivative in terms of y only. So that means no x and no y. So we need something for y prime. Well, what does y prime equal? Well, we have an equation for y prime. We just found it, x over y. So we're going to substitute that in for y prime here. So go ahead and do that, and I'll pause it and come back. Okay, this is what you should have. Now, we've gotten rid of the y prime, but we're still in terms of x, and the direction said we don't want an x. So if you simplify this, you'll get an x squared over y, which still doesn't take away the x. So what we want to do is get rid of this complex fraction. So we want to multiply by our common denominator. So our denominator here is y. So I'm going to multiply the denominator and the numerator by y and simplify. So we have y times y is y squared. And in the second term, we have x squared, and then this divided by y multiplied by y is going to cancel, so x squared. And now, hopefully, you can see what's going on now. So that is y squared minus x squared over y cubed. And if I rewrite this a little bit, we get the negative x squared minus y squared over y cubed. And I know I can't see it on the screen, but if you look up at the top, let's see if I can get there. Nope, it's not going to let me get there. If you look back up at the top, the problem, the original equation was x squared minus y squared equals 25. So then we have our final answer, which would be, and my pen is not working. All right, here we go. Negative 25 over y cubed. And now we have the final answer in terms of y alone.